Good morning, everybody. So, as our theme is that bridging the gap, theory and practice. So, our topic is the basics of ultrasonography. As we all know, for the basically regional anesthesia nowadays, ultrasonography is quite common. If I will give you an example, in the dark room, you are just walking a 4-step forward, 2-step right, 1 step forward, and you are reaching to some object. That is like a blind block. If that object is making some noise and you are reaching up to that object, that is like can be a PLS guided block. And if in the room there are a focus are there and you just go and find that object, it is like a USD guided block. So if it is so easy, then why it is difficult? It is difficult because you have to know how to focus that light. If your light is not focused properly, then you are not going to find that object and it is going to be difficult for you to find the object. Okay, and at the end you will just drop it, just go 4 steps right, 2 steps left and reach the object. It is happening with us all. As we all know, so we are going to put some light on the basics of ultrasonography. Why the basics is needed? Because nowadays you must have find, we know the videos from the workshop, we know how to find the sonoanatomy, what is the brachial plexus and everything. And we reach our hospital and we ask, bring the ultrasonography machine. Today I will give you a USG guided block. The ultrasonography machine came, but the screen is showing something black, something white. We don't know, then we shouted, where is the technician? There is something wrong with the machine and everything, blah blah blah. And again we ended up with a 4-step forward, 2-step right, 2-step left, our blind technique. So this is happening because we are not knowing. So when the ultrasonography machine is there, our face become like this. We know everything but we can't do anything. But if know something basics about the ultrasonography, then we become confident like that and we can perform our block very well. So for that we have to know the physics, basic physics. It is very basic physics. Like what is the ultrasonic wave? Ultrasonic wave is the sound wave is more than 20,000 hertz. Okay, which we can't hear. And here we are using up to 2 lakh hertz, more than 2 lakh hertz, 2 megahertz we are using. And then how these waves are generated? These waves are generated by the effect of the piezoelectric effect. What is piezoelectric effect? Piezoelectric effect, how it here works? Ultrasonography machine, electric current has just passed, it is reaching to the probe. In the probe there is a piezoelectric material. That electric current is generating the mechanical energy, vibration in the probe, and it will generate the sound wave. So here it is a reverse piezoelectric effect. That sound wave hit to the object or subject, come back and again hit that your piezoelectric particle and it will generate an electrical current. So it is a piezoelectric effect. So initially reverse piezoelectric effect and then piezoelectric effect will generate some view on our screen. So now we imagine like in the OT room we have asked for the ultrasonography machine. We know now the basic. We are now going to open the ultrasonography machine. We have opened the ultrasonography machine. Now we are confused. What mode is going to be used? So in the ultrasonography machine, basic 3 mode. A mode, B mode, M mode. A mode is an amplitude mode. When the currents come back, whatever the object it has hit, it will show the amplitude. Just something has hit it and it will just show you the amplitude. That is the A mode, 1-dimension mode. Then the second is the B mode. B mode is a brightness mode. Here because of the object, there is a 1 dot is generated. So you can know something has been hit by the sound wave and that dot has a brightness. It can be dark or white. Depending on the brightness, we get some 2-dimensional effect, 2-dimensional information. So it is a B mode. For all our anesthesia purpose, for the block or central line calculation, we are going to use B mode. And the third mode is a M mode, where motion mode is also involved. It is called as the motion mode. Here it is mainly used for the echocardiography, for the valves and all those information. So after knowing these things, we have to know, like on the screen I will find something black, something white, but that have some name, that they are hyperechoic, which is a like whitish. It is a like dark, that the isoechoic. It is like a surrounding structure, that hypoechoic and anechoic. Anechoic is a totally black, and depending on this structure, we are going to differentiate the things. Now, as the machine has started, now it is the time to select the probe. Which probe we have to select? We have to go back to the physics again. Now, what happens when sound wave is generated, the sound wave hit the object or subject and then it comes back. When it comes back, then only the that sound wave is going to be generated. And frequency is that how much sound waves are generated in a fixed time. So if the probe has a high frequency, it means the previous wave has to come back fast. It means the depth wave is going to pierce is going to be less. So with a high frequency, your depth is going to be less, but your resolution is going to be good because there are more frequency. And with a low frequency probe, your depth is going to be more, but your resolution is not good like a linear, like a high frequency probe. So we will remember, linear probe is a high frequency probe, whereas the curvilinear probe is for the low frequency probe. So if your desired structure where you are going to block or you are going to cannulate, it is deep, then you are going to use curvilinear. If it is superficial, you are going to use a linear probe. After selecting the probe, we have to know how we should hold the probe. If you hold the probe just put on the screen, you are going to give a too much pressure or less pressure. In that case, you have to take the support of the patient's body and hold the probe. So you can control the probe. Okay. And now after holding the probe, you have to move the probe. So you can to find the desired structure, you can move the probe in a different way. One is a sliding. You are just moving the probe. Here you can see. Then there is a tilting. Your probe is holding and you are just raising a marching. That is a tilting. Then there is a rotating. You find the desired structure in the center and to cannulate in a long axis, you are just rotating the probe. One movement is that head and toe rocking. What is the rocking movement? Here, you are just moving the probe. Why you are moving? If your needle entry is far and you want to trace the needle from the far, you can use that movement. And the final one is the compression movement. Compression movement is to differentiate between the artery and vein. You have to use that compression movement. So all these with far movement, you can control your probe. Now, probe, how you put it? You can put it probe in the longitudinal axis as well as the transverse. Transverse is like transverse and longitudinal axis is in the axis of that organ. Now the important part, there are many switches on your desktop. What to select? First is the depth. Before giving any block, you should know like at what depth your desired structure is going to be there. And according to that, you have to select your depth in advance. It does not look like good, like you are just decreasing 15 centimeters, so supraclavicular block, and you are decreasing and come to the 3 to 4 centimeters. So you should know at what structure your desired structure is going to become. Then there is a frequency. With the linear probe, which is a high frequency probe, it has also some margin, 5 to 20 Hz. So according to you can set the frequency also. Then the brightness and the gain. Brightness and the gain will decide like how nicely my structure will look and how black structure will look. So how you will decide? Your vessels should look anechoic. That should be a standard point. By just increasing the whiteness of the nerves, you can't make your vessels isoechoic. Okay? So your target should be an anechoic vessel. That much brightness should be there. And there is a time grace here. What is a time grace here? Here whatever your picture is seeing now, that is basically a time travel. The first wave is generated, the superficial object it has hit, it has come back, and that first image is produced. Then the wave go more deeper and come back. So the lower image and lower image. So it is a just initial image is the first image, and after the fraction of seconds, the other image is generated and the full image is generated. So in the time grade, then according to what time the wave has come, we will highlight it. So if we want to highlight this now, we will say, you can see the TGS. If anybody has used the USG machine, they must have seen that if you want to give a bright structure, you will move all switch to the one side. But then everything becomes bright. But we should know which wave is going deeper, it becomes weaker. So we have to strengthen that wave only. So ideally it should be like a oblique. For the superficial structure, it should be on the left or middle, and then slowly it should go right. And then your whole picture is become like equivalent. Okay? So that is a TGS. Then in your machine, there is a focal point is there. If your desired structure is at the center, you can set your focal point length and that structure can be highlighted more, so it is easy for you to give the plot. And the final one is a Doppler. Doppler is basically to differentiate between arteries and veins basically. You can do that. Now, after putting the probe and knowing everything, we came to know like how the structure, it is a like so anatomy whole thing, but if you understand like basic thing, if there is a less resistance, then wave will easily pass through and it will look black. And if there is a resistance is more, then wave will come back and it will look like white. So if the water content is more and air is there, so air, blood, fluid will look anechoic. If there is a somewhat less water content is there, muscles, nerve, then it's going to be a hypoechoic. But if the water content is very less or not there at all, then bone, tender, nerve, it is called as a hyperechoic. So in that way, we will differentiate our structures. So now looks like ultrasonography is very simple. I can do anything. But now these questions arise. Like why some bones look hyperechoic and some are anechoic? How come the bone and pleura both have a different structure, but both look same echogenicity? And why same structure sometimes look hypo and sometimes look hyper? And now sometimes look hypoechoic, sometimes look hyperechoic. So to know these answers, we have to dive a bit more. Here, what the wave is generated, what happened with the wave? First is the reflection. Wave just hit, come back and generate the image. But to generate that image, the angle should be less than 90 degrees. If the object is flat, then hitting it and coming back, nice white bone, hyperechoic, good bone you can see. But if it is abnormal, it is hitting here and it's just going away. Receiver is not going to receive any wave. Then the same bone or same thing, irregular bone, will become black. Okay. Then the one more thing is a refract. So angle of incidence is important thing. Then for the reflection, acoustic impedance and acoustic impedance mismatch. These are really interesting. What is acoustic impedance? Like how much resistance it is gaining. And acoustic impedance mismatch means, like if I give an example, if I am walking with a very fatty guy and anybody can ask who is Dhairya, then everybody is going to say that thin guy is Dhairya. But if I am walking with a 40 kg guy and anybody asks who is Dhairya, then the same people is going to say the fatty guy is Dhairya. So if my two structures which has a very wide acoustic impedance, if my pleura which is a high acoustic impedance but below air is a very low acoustic impedance. So that's why pleura will look more hyper. Got my point? So same way the surrounding structure is how it will decide that acoustic impedance and it will generate the picture. Then there is scattering. In the irregular mode, waves are just disappear surrounding and you will not find anything. Then the refraction, when the passing through the one medium to the other medium, it will just deviate. We have to remember that thing. Then the other important point is attenuation, absorption. When the any waves is generated, because of resistance and everything, some power of the wave is going to be absorbed and wave is going to be weaker. So that's why whatever the frequency, it is dependent on the frequency. So if your frequency is low, then your wave's depth is going to be more because here attenuation is less. But if the frequency is more, then that depth is going to be less because attenuation is very high. So for the now, like because of time limit, now after recognizing any structure, we want to go to needling. There are two ways of the needling can be done. One is an in-plane approach. Here the whole angle we will see, and the other is an out-of-plane approach. Here we are just entering. For the in-plane approach, the angle should be less than 30 degrees. They have only better visualization. Whereas for the out-of-plane approach, good to have a steep. So you are just remaining nearer to the edge of the probe, as you can see. But after this thing, there are many questions arise. What is the artifact? There are some mirror images generated because of the same thing. Then there is going to be reverberation. Okay, that commented as well as when the needle is passing, we can find that. Then there is a refraction, acoustic enhancement, and acoustic shadow is going to be there. It will again take about 10-15 minutes because of time limitation. We are not going to in that detail. So like this is going to be a basic ultrasonography detail. If you go with these details and you control your movement, you will keep dhairya, not me, but patience. If you keep patience and hold your probe, not haphazardly try to find the like your targeted place, but you are just going to find what you are seeing, and according to that, if you try to find your desired entrance, and then only you can give a very good block, and it is going to increase your effectiveness of the block, as well as now the light has been focused properly, so your time to give the block is also become a very minimal, and it can become very perfect. Thank you very much.
Thank you, Dr. Dhairya. Thank you so much, sir. I would like to invite Dhruva ma'am to please